We are beginning the new unit on branching. This is kind of how the cadence of the class will go. We finish an assignment, which we did on Wednesday, and then we move on to the next unit. This one's called branching. A couple things first that you need to be aware of for the test. This is not on the worksheet. Maybe I should have put it on the worksheet. Yeah, it's not on the worksheet. When you're building your program, there are building and running your program, there are three different kinds of errors that you need to be aware of. You've already run into probably one or two of them. Well, you probably run into one. The project simply won't build. That usually means you misspelled the word int, or you named your variable a lowercase c and you were trying to reference it in a formula with an uppercase C, or something like that. You have a syntax problem, you're missing a semicolon, something like that. When that happens, the compiler stops you right there then and asks you the dumbest question, which is, do you want to run the old good one, or do you want to stop and fix the errors? You always want to say no to that question and stop and fix the errors. If you say yes, it'll just run the old code, but you have your new code that you've typed up that can't build. So I don't know how that helps you. So there's a syntax error. The next time is a runtime error. A runtime error some of you ran into. For instance, when you typed letters in one of your boxes for the calculator assignment, and you clicked on and said calculate or add, and it said, I don't know how to convert the letters ASDF to some integer value. That's a runtime error. It crashes. Usually it's what's called as throwing an exception or runs out of memory, something like that. And the third one is a logic error. A logic error is where you have come to a point in your code, and instead of going to run through your addition code, you incorrectly wired things and you clicked on the add button and it goes to do multiplication. It's like, that's not what I intended. You got things wired up wrong, or you've got the logic set up wrong. We're going to learn about this kind of logic in what's called branching. Those are the three kinds of errors. There will be a question on the test related to this. Syntax error, runtime error, logic errors. Typically, those are the three kinds of errors that you run into. The runtime are usually, well, actually, the logic errors are usually the hardest one to find, because your code's running, and it appears to be running fine, but it's not doing what you thought it was going to do. So we have talked about declaring variables. Declaring variables is declaring a memory storage space to store some kind of data. The types that we know about up to this point are string and integer. Talked about that in the bonus question. The variable assignment, you have the variable name on the left side, an equal sign, and then whatever the expression is will be assigned or copied into that variable for storage. We've gone through expressions, how you can take multiple individual expressions and link them together with operators. Operators are like the plus sign. An expression could be 1 plus 2. 1 is an expression, it's an integer value of the value 1. 2 is an expression, integer value of 2. Plus sign is the operator that says add the two together, and it creates a new integer value that is 1 plus 2, which is 3. And then you can take that expression and assign it into a variable or use it in a larger expression. Yeah? Oh, this is old school.
Now let's see. Where was I? I wonder which way I ought to go.
That's better.
Now, where in the world do you suppose that?
Lose some.
Oh! Well, I was, no, I mean, I was just wondering.
Oh, that's quite all right. One moment, please. Ooh. Second chorus. 'Twas brilliant, and the slithy toves did beguile and gimble in the way.
Why, you're a cat.
A Cheshire cat, all a mimsy. Oh, what a goes.
Oh, wait. Don't go, please.
Very well. Third chorus.
Oh, no. Thank you, but I just wanted to ask you which way I ought to go.
Well, that depends on where you want to get to.
Oh, it really doesn't matter. As long as I can...
Then it really doesn't matter which way you go.
I warned you about Disney, right? Okay. That's a fun little example of branching. Alice gets to a point in the woods and doesn't know which way to go, but in her case, she doesn't care where she goes. You care where your code goes. And you're going to code it up correctly so it goes to the right place. Long time ago, okay, we're introducing a new type. Up to this point, we had integers and strings. We're introducing a new type. It's called Boolean. Long time ago in a land far away, there's this guy named George Boole. That's where the word Boolean comes from. George Boole was a mathematician, if I'm not mistaken. And out comes this new data type. We're not going to go into all the history of how it came out. Instead of using int or string, you use the keyword bool, all lowercase. Booleans can store, so integers can store whole numbers. They can't store decimals, they can only store whole numbers. Strings can store a string of characters. You can put numbers in there as a string of characters, but a string is a string of characters, or null for nothing. A bool can store one of two things. It is either true or it is false. It's nothing in between, nothing else. If you try to put a number into a bool, it will give you a syntax error saying, I can't do that. It's the same as if you were trying to assign a string into an integer. It would say, I can't do that. Or if you're trying to assign an integer into a string variable, it would say, I can't do that. That would be a syntax error. It wouldn't build. Boolean values have either true or false. And you type it by typing the word true or false, all in lowercase, no quotes, no other punctuation. Keep that in mind as we talk about a branching statement. This is called an if statement. Everything in the purple are pieces that you type or characters that you type in your code. Inside here is a Boolean expression. So what's the value of the Boolean expression going to be? It's going to be true or false. It's not going to be 7. It's not going to be the string of something. It's just going to be either true or false. This guy says, if this Boolean expression comes out to the value of true, I'm going to come in here and do whatever statements are inside here. Like it's just a group of lines, group of statements, group of code. If this is false, I'm going to skip over all of these statements and then continue on down below. This is the most simplified way of doing branching, where you make a decision point in your code. You can also do what's called if-else statements. It's the same as an if, but it just has this extra tacked on to the end of it, where there's else and there's the two braces and statements. If this is true, it's going to come in here. If it's false, it's going to come in here. So if you have an if-else statement, at least if you have an if-else combination here, no matter what, either this group or this group will be executed, but not both. Never both. It can't be both true and false. It's either true or false. And so it'll either come in here if it's true, come in here if it's false. We'll show you some real-world examples here. The numbers game. Should have had this open already. Fortunately, it should open up quickly. This is a very small program that uses some if statements to walk you through the numbers guessing game. The numbers guessing game goes something like this. You say, I'm thinking of a number between 1 and 100. I have chosen the number, and now you're going to try to guess it in as few steps as possible. It looks like this. Really, it does look like this. Speedy. I have a new computer coming. Wow. Very sorry for the slowness. All right. So the computer has already chosen a random number between 1 and 100. So tell me your guess. 71. So I'm going to put 71 in here. I'm going to say guess. That's too high. Now it says, okay, well, it's between 1 and 71. 32. That's too low. So now it's between 32 and 71. 51. Too high? 41. You guys are really good at this. 49. 46. 42. 44. Ta-da! I should have told you how many guesses, but you get the idea. The code, let's show you a little bit about what the code looks like. I don't have any errors. It has these if statements. See how they're kind of highlighted in blue? It also has what's called an else if. An else if is like an else statement, but with also an additional if. If this were true, it would put in a message and say, that's right, we saw that message. If it's false, it's going to come to this else if and go through this logic. We'll talk about that logic in a minute. If that logic is true, it would come in here and say that's too low. If this is false, it's going to come down here to this next else if, look at this logic, and if it's true, it'll say that was too high. If it's false, it's going to come down to this final else down here, and it's going to say, you guessed something out of range. We didn't see that one. That's the dumb one where you would say, pardon me, not dumb, it's the less than wise choice, where you guessed 49 and it says that's too high, and then you said, okay, 53. It would say, bozo, that's out of range. Okay, and then it would say again, guess a number between whatever the numbers are. This is what an if and else if looks like in code. We'll walk through that here in a minute. So one of the things that this program did was it automatically generated or computed a random number. If you look on the back of your worksheet, there's stuff on the back too. Question number 4. A random number takes 2 steps to create a random number. The first step is you need to create a random number generator. That's what this line does. It creates this engine, if you will, that will give you random numbers whenever you ask for it. So the very first line of question 4 says, how do you create a random number generator? This is a variable name. Essentially, this, you can think of this as a type, but don't worry about it right now. This is a variable name. It could be R. It could be RNG for random number generator. It could be the all-knowing I, whatever you wanted to call it, inappropriate camel case letters. But this is how you create a random number generator. This is the part that is your variable name, that you can choose to have any variable name there that you want. Usually something meaningful is nice. Then to use the random number generator, here I'm saying int, some random number. This is a variable name called random number equals, I had to wrap it to 2 lines just so it would fit on the screen. Whatever name you used here, you use here. So you say random dot next, and then you give it a minimum value and a maximum value. Now this is saying a random number between 1 and 10. You might think that it would make sense to say, well, the minimum value is 1, and the maximum value is 10. So you put a 1 and a 10 there. That would be wrong. Because of why? Okay, if you know the answer to this one, I'd be impressed. All right. The minimum value is an inclusive bound or boundary, meaning if you say 1, it can be 1. The maximum value is an exclusive boundary, meaning if you say 10, it can't be 10, but it could be 9. And so if you want between 1 and 10, you would say 1 comma 11. This one goes to 11. Name of the movie reference? No one. This one goes to 11. Okay. If you figure that one out, let me know. Sorry, cheap humor. So for the answer to question 4, I think it's 4B. You're creating a random number. So this can be any variable name that you choose, following camel case rules. This needs to be the same variable name that you used previously on creating the random number generator. The values, though, are fixed because it says between 1 and 10, you want it to include 10 and you want it to include 1, so you'd say 1 comma 11. Seems a little screwy. It kind of makes sense later on down the road, but does that make sense? Ish? Mostly? Okay. I can only see your eyes. I can't see the puzzled look on your face. Okay. That's random numbers. Now, we previously talked about operators. We talked about operators for math calculations. Plus, minus, times, divide, and what was the 5th one? Incorrect. That was not. There is no average operator. Anybody remember the name? It's going to be on the test. Maddie? Modulus. Aha. When is the test? It's coming up after we get done with the next assignment. It's a little more than a week away. Yes, I will have a review before the test. We'll kind of do a dry run. Relax, no worries. You're going to get this. All right, so we've got the 5 mathematical operators, plus, minus, times, divide, and the percent sign, which is the mod or modulus operator. It gives you the remainder from the long division. We also have a string operator, which is also the plus sign, but the plus sign automatically does concatenation when there's a string involved on either side of the expression. So the plus sign can be addition, or the plus sign can be concatenation, depending on if strings are involved. We're introducing some new operators that go along with branching and Booleans. There's the double equals operator. Double equals is the is equal to operator. This simply says take this value or this expression and this expression, First off, these two values or expressions must be the same type. So you can't compare an integer to a string. Doesn't make sense. Is integer 1 equal to the string, quote, hello? It's like, that doesn't make sense. You don't compare strings to integers. So they both have to be the same type. So it could be strings on both sides, or it can be integers on both sides, or it could be booleans on both sides. Because that's our world of our data types today. Int, string, bool. And it just simply, this is double equal, which is different than the single equals. This is going to be really hard for some of you. Single equals is the assignment operator. It just takes what's on the right and assigns it into the variable on the left. It's a very special purpose. It's the only assignment operator. This one is double equals that says, compare these two. If they're equal, I create a true value. If they're not equal, I create a false value. So the result of this expression is based on what these values are, and it's going to, this double equal, or this comparison operator always creates a Boolean. It's either going to say true or it's going to say false. The next one is an exclamation point followed by an equal sign. This is not equal. Those two characters together make an operator that takes two values, just like the equal sign, that the values or the expressions on either side must be the same type. And it just looks at them and says, are these two not equal to each other? Oh, they're not equal? True. Oh, they are equal? False, because they are not equal. This one's a killer. It's the less than operator. It looks at the two expressions and says, is this first value or expression less than the second value? This one only works with ints and strings. Strings is looking at to see if it's alphabetically before or after type of thing. Just use it with integers for now. Don't worry about the string part. You can't compare bools. There's nothing greater or lesser than true or false. I mean, they're not. So you would have an integer value and an integer value, and it would say, hey, if this one is less than that one, true. If it's not less, if it's equal to, if it's 10, is 10 less than 10, it would say false. 10 is not less than 10. Greater than, same thing. Same thing, only opposite. Same thing, only different. Less than or equal to. It's the same as less than, but it adds the equal character in there. So it's saying, is this value or integer less than or equal to that one? So if this one computes to 10 and this one computes to 10, it would say true. But if they're both 10 over here, it would say false. All these comparison operators always create a Boolean, so it's always going to be true or false. Greater than or equal. Same thing as greater than. Make sense? You've dealt with these in algebra. Okay. So those are the comparison operators. You should be following along quite nicely on the worksheet. You got half of question 1 done. Logical operators. Logical operators take two Boolean expressions. These have to be Boolean expressions. And you put a double ampersand there, and that means and. And means it'll give you a true value if both sides are true. Is this true and is this true is really what this is saying. And it will give you a true value if both are true. So if either of these are false, or if both of them are false, it will say false. This one, it's two characters. It's typically on your keyboard. It's right above the Enter key, the shift of that backslash. This is OR, typically referred to as OR. Is this true or is this true? Or is true if either of them are true. So if this is true and this is true, it'll say, yep, they're true. The resulting expression is true. if this is true and this is false, or if this is false and this is true, it'll say true. Because if either side or both sides are true, it will say true. The only time that the OR operator says false is if both sides are false. Bored to tears yet? Okay, this is the interesting operator. This is the not operator. He only takes one value, and that one value must be a Boolean value, and it just swaps it. So if this expression results in true, it'll say, okay, false. Or if this results in false, the not will make it a true. It just takes whatever the Boolean value is and swaps it to the other side. So these are the three logical operators: and, or, and not. It's just an exclamation point. Having fun yet? Okay. So I showed you about the else if, and else ifs can go on and on forever if you want to. We won't have need to use else ifs in this class. You're welcome to. You won't be docked points, but they can get kind of complicated. Now we're going to hold off on going to the dice game right now. I'm going to go to the worksheet, and we're going to kind of work through the worksheet together. Really? All right. You should have section 1 done, and you should have section 4 done. If you don't, ask your neighbor for some help, but very quietly to not disturb the rest of the class. All right. Right on the board, so those on the video aren't going to get the benefit of seeing all this, but I will. All right. We have these three variables declared in our little world. We have an integer variable called score. Oh, great, thank you. It looks like a form. We have an integer variable called score. It has a value of 10. We have an integer variable called count, and it has a value of 7. And we have a string variable called name, and its value is, quote, John. It's the string John. So here we're using one of these new comparison operators. This is greater than or equal. So score is 10. So in my mind, I'm just going to pencil in a 10 there. I'm going to say, is 10 greater than or equal to 7? It is. So this is true. Is count equal to score minus 2? Well, I've got to do score minus 2 first. But I can put, for count, I can say that's a 7. For score, that's a 10. 10 minus 2 is 8. Right? That's the resulting value of this expression. So is 7 equal to 8? No. See, this is easy. Is name not equal to Sam? Well, name is John, so I can just substitute in my mind John there. That is correct. This is true. John is not equal to Sam, the string characters. So this is true. See how that goes? Score minus 3 not equal to count. You always kind of go to the expression, the inner expressions first. Score minus 3. Well, score is 10. 10 minus 3 is 7. And count is 7. Is 7 not equal to 7? Actually, they are equal, so this is false because it's not equal. See how this goes? Now we get to the little more compound ones on E. Score is 10. Count is 7. So I do these score greater than 5. That is true. 7 greater than 10. That is false. With and, so I have true and false. What's the resulting? False. It's false because and both sides have to be true. So this is false. I'm going to run right on down to the hardest one, which is I. Sorry it's so low. I can maybe raise it up a little bit. No, everything's lined up wrong. Okay. If I wanted to read this out, I would say the not of count less than or equal to 10 and the not of score not equal to 10. Okay, let's just pick one of the inner parentheses. I'm going to start with score not equal to 10. Well, score is 10. Is 10 not equal to 10? This is false. So the not of my false makes this true. So that side of the and is true. Right? Count, which is 7, is 7 less than or equal to 10. That is true. The not of it makes it false. So now I have false and true. Well, with and, they both have to be true. So this is false. Anybody have any questions about any of the other ones that we didn't go over? Kind of giving you all the answers. Okay? I don't see any hands going up. Let's go to section 3. We're going to write a little code snippet. We're going to say if count is equal to 0, then we're going to change the score to 10. So we know if statements always start like this. Those are my curly braces. Aren't those artistic? Okay. So I have an empty skeleton of an if statement. Let's go to the inner part first. Score equal to 10. I want to, inside my if, I want to set score to 10. Or score to 100, pardon me. So I just say score equals 100, semicolon. Right? So that's what the body of my if statement is. What's the actual if statement? If count is equal to 0, how would that go? Max, how would that go? Okay, Sean?
If count equals 0.
Count double equals 0. So you have it, this says if count is equal to 0, if count is equal to 0, then go to the body, score is set to 100. Let's go to B. If score is more than 5, increase count by 2. So we'll create the skeleton again. Increase count by 2. To increase count by 2, I would just say count equals count plus 2, semicolon. Notice there's no semicolon at the end of the if statement or these braces. If you were to put a semicolon here, it totally changes your world and does not do it at all. This is a logic error if you do that. Don't do that. At least one of you is going to fall into the trap. I hesitated to even put on the board, but I took it off the board really quick. So we got an if expression. We got a Boolean expression to put in here. If score is more than 5. Mia? If score is greater than 5. Perfect. Any questions about A and B for number 3? (3C). If score is more than count, then decrease both by 2. What does decrease both by 2 mean? So we're going to have some if statement. I'm going to put, the skeleton of the if statement. I'm going to decrease both by 2. Well, I'm going to decrease score by 2 and count by 2. There's going to be 2 separate lines in here. I'm letting you do a little bit more of your own. The if statement is very similar to what we did on 3b, but this is saying if score is more than count. Score more than count, more than means the greater than sign. Same thing, different words. You can figure out what to put in there, I think. Can you? D, if count is between 7 and 15, then decrease score by 5. This is a tricky one. I'll walk you through this one. So the body, decrease score by 5. Okay, we know how to do that. Score equals score minus 5, semicolon. How do we do is count between 7 and 15. You might be tempted to do this wrong thing. I'm going to write something wrong on the board. Don't write it wrong on your paper. You might be tempted to say, oh, between 7 and 15. If count is between 7 and 15, 7, count 15. You might be tempted to do that. Where does that go wrong? Well, with order of operations, these are equal, so it's going to do these 2 first, right? This won't even compile, but let's just say it tried to compile. It would say 7 less than count, 7 less than count. Okay, so let's say count is 10. Is 7 less than 10? Yeah, that's true. True less than 15. That does not compute. The compiler won't even let you get that far. But that's not how you do this compound one. You're going to need to use an AND statement. So one side is count is between 7 and 15. So 7 less than count. That's one side of it. And we're going to glue it together with the other side. The other side is count is less than 15. And we do the AND in the middle. This says, is 7 less than count? Between 7 and 15. 7 less than count, and count is less than 15. That's saying, is count between 7 and 15? Using the AND sign. Maddie?
Would it be wrong if, like, the beginning was count greater than 7 and 0?
You can do it. So this can be written the exact same way. It results in the same. Count is greater than 7, and you could do, and 15 is greater than count. Yeah, you can. These are equivalent. It's just, however, if you're left brain, right brain, up brain, down brain, whatever, it's okay. It's perfectly fine. Whew, this last one. I'm going to scroll it up to the top so you can see it. If count is equal to 10, or, a nice key word there, or name is equal to Tom, then double the score. Otherwise means else. In your brain, you should be thinking, oh, that's the else part. Add 10 to the score. Okay, so we're going to have some kind of if statement. And we're going to have some type of else portion of that. I'm going to start with the else portion. The else portion, or the otherwise portion, is add 10 to score. Okay, score equals score plus 10. If it's true, then I'm going to double the score. So I'm going to say score equals score times 2. I'm just kind of working backwards here. Now for the big if statement, the expression, if count is equal to 10, I know how to do that. Count is equal to 10. And it says, or, the 2 pipe symbols, or the name is equal to Tom. Name is equal to Tom. Excellent. Any questions or problems on the worksheet? We've kind of gone through the whole worksheet, handed it to you on a silver platter, except for a couple. Anybody need any more detail? Okay, please start Visual Studio. And before you leave, I need you to turn in your worksheets. On your way out, by the hand sanitizer, you'll just leave your worksheets here. I'll grade them and return them to you on Tuesday. I hope your writing is legible. If it's not, it will be very difficult for me to give you a score. I'll stop my recording now.